እንደምን አላችሁ የሳፐሪ አካዳሚ ቪዲዮ ዩቲዩብ ቻናል ተከታታዮች የዛሬው የሁለተኛ ቪዲዮአችን በተርሞዳይናሚክስ ሲሪስ ስለሚቀርብ ስለ ተርማል ኢኩሊብሪየም እና ስለ ዜሮት ሎው ተርሞዳይናሚክስ ምናይበት ርዕስ ነው የሚሆነው። ስለዚህ የዛሬው ትልቁ ርዕሳችን ምንድነው የሚሆነው? ተርማል ኢኩሊብሪየም እና the zeroth law of thermodynamics. የዛሬ ሁለቱ ርዕሳችን እነዚህ ነው የሚሆኑት። ናው ተርማል ኢኩሊብሪየም እና the zeroth law of thermodynamics በጣም መሰረታዊ የሆኑ በተርሞዳይናሚክስ ውስጥ ሌሎች ህጎች ቤዝ የሆኑ ህጎች ናቸው። ናው ከመጀመሪያው ስንነሳ ስለ ኮንሰፕት ኦፍ ቴምፕሬቸር ትላንት አንስተን ነበር። በዚህ አይዲያዎችም ስለ አንዳንድ ነገሮችን አይተናል። ዛሬ ደግሞ የምናየው እዚህ ጋር ምንድነው በኮንሰፕት ኦፍ ቴምፕሬቸርን ለመረዳት በተርማል ኢኩሊብሪየም ስር we need a careful definition of terms of thermal termoችን definition ያስፈልጋል ብለናል። ስለዚህ ከዚህ ሳንጀምር በፊት መጀመሪያ let's try to explain some terms። የመጀመሪያው ኤክስፕሌን ማድረግ የምፈልገው ተርም ምንድነው? ስለ ሂት ነው። ናው ሂት ያለፈው አመት ግሬድ 11 ፊዚክስ ላይ ተመራችኋል። በዚህም ሂት የሚለው ስናይ ለምሳሌ ሂት is simply an amount of energy transferred between bodies or between a body and its environment due to temperature difference. ስለዚህ ሁለት ቦዲዎች ወይም ሁለት አካሎች suppose ለምሳሌ እዚህ ጋር let me suppose that I have የሆነ አካል A which is simply found at some initial temperature A ልበል and suppose that I have another body እዚህ ጋር which is simply found at temperature B. አሁን እነዚህ ሁለቱ አካሎች if I put them in contact ለምሳሌ ባያይዛቸው እንዲነካኩ ባረክ because of the difference in their initial temperatures, because TA is different than TB, heat is going to flow. So heat is going to flow between these two objects. Now heat is energy. As a result, the heat unit is going to be the unit of energy, which is joule. And thus, the unit of heat is going to be the joule. That's capital J. Now, heat but joule it's also energy transfer. Now, energy transferred means it is not something intrinsic. Intrinsic የሆነ quality አይደለም. It is not intrinsic quality. Heat is simply going to be something that existed when there is energy transfer due to temperature difference. So when you have this value, then you say that heat is there. Now, suppose that you have bodies. የተለያዩ ቦዲዎች አሉ. To the extent that እነዚህ ቦዲዎች መካከል heat or simply energy can be transferred because of temperature difference. እንደዚህ አይነት ኮንዲሽን ከተሟላ then these bodies are said to be in thermal contact ናቸው እንላለን. Suppose that you have some body A again and another body B. Suppose that the temperature of A is equal to the temperature of B, temperature at initial temperature. As a result, heat ምን ያደርጋል? It's going to flow አይደለ? Since A has the higher temperature, it's going to flow ከዚህ ወደዚህ. Because number one, there is energy flow. There is energy flow in the form of heat. And that energy flows because of differences in temperature, which means there is a temperature gradient. We say that እነዚህ ሁለቱ ቦዲዎች are in thermal contact እናለን ማለት ነው. So they are in thermal contact. So an object in thermal contact means heat flows in or out the bodies ከሆነ then these systems are simply in thermal contact. Now we can take an example of that. ለምሳሌ ሻይ ስናማስል በሞቀ ሻይ ውስጥ ይሄ ቲ ሻይ አለን እዛ ውስጥ ለምሳሌ የሆነ ማንኪያ ሱካር እናስገባ ማንኪያ we know that ማንኪያው ስናወጣው is going to be hot. That is because these two objects, the tea and the spoon, were in thermal contact. they were in thermal contact. That is, heat has been flowing from the tea into the spoon ማለት ነው። Now, በዚህ ጋር አንድ ማወቅ ያለብን ምንድን ነው? If two objects are in thermal contact, that does not necessarily mean, it doesn't necessarily mean they are in physical contact. Now, ሁለት ኦብጀክቶች በቴምፕሬቸር ዲፍረንስ ምክንያት ሂት ሲለዋወጡ they necessarily physical contact መኖር አለበት ማለት አይደለም። We know that heat can flow in three methods. Temperature contact ሆነ it can flow through convection, conduction, ለምሳሌ it can flow through conduction, convection, and through radiation. የመጨረሻዎቹ ሁለቱ they do not require physical contact between the both objects for the transferring of heat. And thus ግዴታ physical contact መኖር የለበትም. So when there is a net thermal energy transfer between objects, this process is what we call heating. So heating is simply the process where there is a net heat flow between bodies. Now I said net heat flow. This our definition of thermal contact is going to help us in defining thermal equilibrium. Now, what is going to happen when two bodies would not exchange energy? When ሁለት ያሉት ቦዲዎች they're not going to exchange energy በሂት መልክ ባይለዋወጡ እንደምንለው ይህ condition is called thermal equilibrium. And so thermal equilibrium is a condition in which objects would not exchange energy in the form of heat in any way ስንል either by contact ሊሆን ይችላል or by electromagnetic radiation ሊሆን ይችላል in any way if they were placed in thermal contact ማለት ነው። እንደዛ ማለት there is no net transfer of heat. So if there is no net transfer of heat, that is the process of heating doesn't exist. Even if these two objects were simply put in thermal contact, but there is absolutely they won't exchange energy, then we say that the system is in thermal equilibrium. Now, this idea of thermal equilibrium is useful because it helps us to define what temperature is. It also helps us to define the zeroth law of thermodynamics. Now, let us suppose that we have two bodies A and B. Suppose that you have two bodies A and B. And now let us suppose that A and B are in thermal contact. They are in thermal contact with another body. They are in thermal contact with body C level, with body C separately. That means the body A and B, they do not interact. A and B don't interact separately until thermal equilibrium is reached. Level. Until thermal equilibrium is reached. Now, when this thermal equilibrium is reached, between body A and body C, and between body B and body C, while body A and body B do not interact at this moment. Now, in system ለመሳል, suppose that this is body A level, and suppose እዚህ ጋር ደግሞ I have body B. Now, let me suppose that መካከላቸው እዚህ we have an insulator. An insulator. That is, it doesn't allow for heat flow. So that heat flow አይኖርም A እና B መካከል. But now let me suppose that እነዚህ ሁለቱ bodies are in contact ከሌላ object ጋር. Let me suppose that this is object C. ብዬ ልውሰድ. They are in thermal contact with this object C. Now በዚህ ጋር system, we know that object A and object B are not interacting because they're separated by an insulator, but they are both interacting with object C. Now let me suppose that እነዚህ ሁለት objects, that's object A እና object C እና object B እና object C ከእንደገና are in thermal equilibrium. Now if they reach thermal equilibrium and if we removed this insulator ከሁለታቸው insulator remove አድርገን and if we allow እነዚህን ሁለቱን bodies body A እና body B እንዲነካኩ ብናደርግ would we observe any change? No. Well, surprisingly, no change is observed. There is no change observed. There is no change in property which is observed. Now, what does this imply? Now, this implies that body A and body B, they are in thermal equilibrium. Because body A first, body A and body C were in thermal equilibrium. B and body C were in thermal equilibrium. So this implies that body A is in thermal equilibrium with body B. የሚለውን imply የሚያደርገው ማለት ነው። ከዚህ we can derive the zeroth law of thermodynamics. So the zeroth law of thermodynamics ከዚህ ነው የመጣው። The zeroth law of thermodynamics. Now, zeroth law የተባለው because it's so fundamental to the definition. Now, we've seen that thermodynamics requires a very careful definition of thermal quantity and temperature. So to define እነዚህ quantities and thermal quantities define ለማድረግ the zeroth law of thermodynamics በጣም basic ህግ ስለሆነ ነው the zeroth law የተባለው. Now, the first law ከሱ በፊት the second law ከሱ በፊት ቀድሞ ስለመጣ ከነገር the first ለማለት ለሁሉ መሰረታዊ ስለሆነ zeroth ተባለ. And so the zeroth law of thermodynamics can be written as two bodies that are in thermal equilibrium separately with another body are in thermal equilibrium themselves. So this is basically what the zeroth law of thermodynamics is. So when two bodies, now remember that this law can be extended to any number of bodies. Any number of bodies ሊሆኑ ይችላሉ. So now if two bodies that are in thermal equilibrium separately with another object or simply another body are in thermal equilibrium themselves. So that's the case. But in a ብናስቀምጥ if two objects A and B are in thermal equilibrium separately with another object C, then A and B are in thermal equilibrium ነው የሚለው። አሁን ይሄ ቀላል ስቴትመንት ይመስላል ስናስበው logically looks very simple ግን ይሄ በጣም ቤሲክ የሆነ መሰረታዊ definition ነው because now temperature የሚሆነውን define አድርገን ወደ ቀጣዩ በqualitatively ከሆነ quantitatively የtemperature definition ስለሚሰጠን ነው። Now በዚህ ማለት እንችላለን then we can identify what temperature is. Now እዚህ ጋር ስናወራ ምንድነው? Now suppose that but how can we identify actually if two bodies are in thermal equilibrium in the first place? የሚለው ጥያቄ ማወቅ አለብን. Now suppose that you have an object በዚህ ጋር a machine simply that measures some physical phenomena simply የሆነ some physical property ነው measure የሚያደርገው. Now suppose that this physical property changes with temperature level. Here for example let me suppose any ያለው ይሄ object for example it measures የሆነ physical property of the object that changes with temperature. እንደዛ ከሆነ suppose that for object A በዚህ machine like measure ሳደርግ suppose ያገኘው ቁጥር I'm going to suppose it was 22.5 level. And then suppose that ይሄ 22.5 ነው. And here this object A I'm going to suppose it's in thermal equilibrium with C. It's in contact with C. And this C is also in contact with another object B level. Now let's use the same event. Since time is also I get the same number level. Now since these two physical properties that changes with temperature is the same for both, we can imply that these two objects are in thermal equilibrium. Now let's use machine G. When I literally put it on B, I also get the same number. Now this implies that object A, object B, and object C are all in thermal equilibrium because this number, the value that changes with a physical property, is constant for both. So let's say, how can we define a temperature? So here we can define our temperature. So temperature is simply a quantity. So temperature is a quantity which determines if bodies, or simply if bodies or objects are in thermal equilibrium. So this implies that bodies, አሁን ይሄ ነው ትልቁ ዴፊኒሽናችን ምንድነው? Bodies with equal temperatures are in thermal equilibrium. So bodies that have equal temperatures are in thermal equilibrium, though the opposite is also true. Bodies which are not in thermal equilibrium do not have the same temperature. Now we can also define temperature as a quantity. Temperature can also be defined as a quantity that determines or shows the direction of heat flow. So this implies if body A is at some temperature TA and body B is at some temperature TB, and if TA is greater than TB, and if these two objects were put in thermal contact, they're going to exchange temperature until thermal equilibrium is reached. So they're going to exchange energy. So they're going to not exchange temperature, exchange energy. They're going to exchange energy until thermal equilibrium is reached. So until your some final temperature for both becomes equal, they're going to exchange energy. So temperature, since the temperature of A is greater, implies that heat is going to flow from A to B. So temperature is a quantity which shows us the direction of heat flow. So it's going to flow from something at higher temperature to something at lower temperature. Now we can also identify that it is an average measure. Here the microscopic definition ደግሞ ስናይ, the microscopic definition ደግሞ, it's a measure. It is a measure of the average random kinetic energy of molecules or particles. That is, the higher the temperature is, implies the larger the average kinetical energy of the particles. በዚህም define ማድረግ እንችላለን ማለት ነው። Now, ከዚህ let us actually do a question. Now, suppose that you have two objects. Now you have two objects, level. Two objects with different masses and sizes and temperature. So if these two objects, suppose that here object A ቢሆን, it is found at temperature TA that has mass MA, it has this shape. And suppose this is TB ቢሆን, it has temperature TB and some mass B. Now if these two bodies are placed in thermal contact, then energy is going to travel, or simply heat will travel. Then heat will travel from A, from larger mass to the smaller one, B, from the object at higher temperature to the lower one, C, from the larger object to the smaller one. You can pause the video and then think about it. Well, I hope you've paused and thought about the question. Now, we remember when we said temperature is a quantity which determines heat flow. It determines the direction of heat flow. And so mass, size, these do not determine it. So the only variable that determines the direction of heat flow is temperature. And thus, heat, we know, is going to flow from something from higher temperature to something with lower temperature. So the answer is going to be B. So we're going to travel from higher temperature to lower temperature across the boundary of the system. Now, from here we must understand something, one definition of an object, which is called the steady state. An object is said to be in a steady state if its situation is not changing with time. So if an object is in a steady state, its situation is not changing with time. The situation is constant. Now in the Zassel, that doesn't necessarily mean that that any body which is simply in thermal equilibrium is in a steady that every object which is in a steady state is in thermal equilibrium ማለት አይደለም. Now to define this, suppose that you have two objects level. These two objects. Suppose that the difference in temperature between these two objects is the same, so it's constant. So at the same interval of time, suppose that they lose a specific constant increment of heat ያጣሉ level. Now in this kind of case, since simply the change or simply the net heat flow between the bodies is constant, so the net heat flow between the bodies is constant through time, it is in a steady state. But is the body in thermal equilibrium? No, because if the object is in thermal equilibrium, the net heat flow must be zero. So that is, there is no exchange of energy in the form, there is no net exchange of energy in the form of temperature. And thus, net change of exchange in heat የለም if it's in thermal equilibrium. But that, since these two bodies, they are exchanging heat in the energy in the form of heat, but with a constant, that Q net is constant, they are in a steady state. They are in a steady state, but they are not in thermal equilibrium. These two objects. So this implies, what does this imply? So this implies if objects are in thermal equilibrium, but the reverse is true, Lizzie. In thermal equilibrium, then they are in a steady state. But the reverse is not true. So objects which are simply in a steady state are not necessarily in thermal equilibrium. So this would be our lesson for today, depending upon the Zeroth law of thermodynamics, thermal contact, and also thermal equilibrium. If you have any questions, feel free to leave them down at the comment sections below. And as usual, the PDF version of this lesson would be posted on the Telegram channel of this channel, which I would provide inside the description. So until next time, bye-bye.